What's up, guys? This is my creative contribution number 14. Today I'll be graphing a hyperbola. And here's the equation. So we know right off the bat that it's a hyperbola because of the minus right there. If it was a plus, it would be an ellipse. And if it was a plus, and if both numbers in the denominator here were the same, it would be a circle. So we know it's a hyperbola. We also know that it is a hyperbola with the orientation that is vertical. And we know that because the positive value is the y, which is vertical on the x and y axis. So those are our givens right off the bat, and a great place to start is to find the center. And we can find the center by taking the opposite of the number in the parentheses. So the x value is the opposite of positive 1, which is negative 1, and the y value is the opposite of negative 3, which is positive 3. And it's a great place to start our graph there, so we'll go, 1 over, and 3 up. So that's our center right there. And in delta math, they use A, B, and C. And A is the vertex or vertices. B is the co-vertex or co-vertices, and then C is the foci. We don't really need the foci to solve this, but if we do need to find it, I'm pretty sure we can find it by using this and solving. But since we only need these to graph, we'll just focus on those. So the co-vertices, or the vertices, excuse me, are going to be the points on the line where the graph touches that are closest to the center. So since we know it is a vertical orientation, we're going to take the square root. Here, let's move this. We're going to take the square root of whatever is in the denominator for y there. So we have 1, which is equal to 1. And then for the co-vertice, we have 4, which is equal to 2. So what that information gives us is, tells us that we have a vertex 1 up and another vertex 1 below. And then the go vertexes are going to be 2 over. So 1, 2, and 1, 2. Whoop, doesn't look too symmetrical. Let's do that right there. And also in delta math, they were drawing a box to make it easier to draw the asymptotes. So we'll just do that. So there's one asymptote and then the other one. Whoop. Trying to make that a little more centered there. So what we know is the hyperbola touches here, and it goes out and never touches those asymptotes. Same with on the bottom there. Whoop. Like so. Like so. And yeah, so there's that. So we're all graphed. The second part of the question there asked us to find the equations of the asymptotes. Okay, so the equation to find the two equations of both of these green lines up here. This is an equation I found online, which is y minus k is equal to plus or minus b over a times x minus h. So the h and the k are the center coordinates. So -1 and 3. And then the a and the b. So the a is the square root of the x denominator, and then the b is the square root of the y denominator. So if we go up here, square root of 4 is 2, and then square root of 1 is 1, and we just plug and play. So y minus k is y minus 3 is equal to plus or minus 1 over 2 x minus -1, which is x plus 1. And then we'll just split this off into two different equations. Y minus 3 is equal to positive 1/2 times x plus 1. And then y minus 3 is equal to -1/2 x minus 1. Wait. Yeah, that's that. I just skipped a step here. And then the next step is y minus 3 is equal to 1/2 x plus 1/2. Y minus 3 is equal to 1/2 x minus 1/2. And then we need to find the common denominator, which is 2. So we'll add 6 over 2 to each side. Y is equal to 1/2 x plus 7 over 2. That's one equation. And then the other one's -1/2 x plus 5 over 2. That's it right there. Thanks.